Hello and welcome to my talk titled You Can Teach an Old Dog New Tricks, Rank Fusion Applied to Coordination Level Matching for Ranking and Systematic Reviews. My name is Harry Scells and this research was developed in collaboration with CSIRO during my PhD. Breaking down the title of this talk, we're first going to touch on what systematic reviews are and their place in this talk, then investigate what coordination level matching is, and then investigate what rank fusion is. Finally, we're going to discuss the contribution of this paper, which is how we combine coordination level matching and rank fusion. We'll then analyze some results and then discuss future areas of research. Firstly, I'd like to provide some background on systematic reviews to frame this research. A systematic review is similar to a literature review. It is the synthesis and appraisal of all relevant documents for a particular research question. Its aim is to be unbiased and comprehensive, and it must adhere to strict guidelines and protocol. This ensures that the review could be reproduced. The figure on the right is a high-level overview of the systematic review creation pipeline. As you can see, there's many steps in the process. Each step in the process gradually refines the total number of studies needed to produce the systematic review. In this example, 30 million citations in a medical database are filtered down to just the 22 needed to produce the systematic review. But there's a big problem here, which is that many of these processes are time-consuming and costly. Currently, systematic reviews can cost over $150,000 and can take 2 years to complete. This talk focuses on one particular stage in the creation of systematic reviews, the screening phase. Here, every single retrieved study is critically appraised to determine if it should be included in the review. Specifically, we investigate two tasks to improve screening: screening prioritization and stopping prediction. Screening prioritization is the ranking of abstracts given a Boolean query, and stopping prediction is the task of estimating if and when the screening can end early, without screening every study. Improving the screening phase allows researchers to begin the later stages of the systematic review process faster and in parallel, as well as improving existing active learning methods, as a better initial ranking increases the rate of learning for these models. As for stopping prediction, as we saw in the funnel diagram previously, most of the studies to be screened will not be relevant to the systematic review, so it reduces the workload required for screening. In previous research of others, there's a number of limitations that we aim to address in this presentation. For screening prioritization, we found that no methods exploit the structure of the Boolean query, and in general, methods rely on contemporary web search-based ranking in a Boolean retrieval setting, disregarding the nested structure of the query. As for stopping prediction, we found that only naive attempts have been made, for example, score-based cutoffs or continuous relevance feedback. To address these limitations, we apply coordination level matching to exploit the structure of the Boolean query for screening prioritization, and then instead of relying on any one particular ranking method, we use rank fusion. As for stopping prediction, we apply a gain-based approach which models how a researcher would screen studies by exploiting the amount of information gained from screening each study to predict when to stop screening. Next, I'll give a detailed description of coordination level matching and rank fusion, and how we combine these two ideas. Coordination level matching is a ranking method designed explicitly for Boolean queries. It's dependent on both the terms and the structure of the Boolean query. The intuition behind coordination level matching is that subclauses of the query are considered separate but related queries. Studies that appear in multiple clauses are ranked higher. However, we found empirically that rankings produced by coordination level matching typically perform poorly, as the amount of information exploited about the query is low. Note that coordination level matching can be weighted with ranking functions such as term frequency. However, these weighted coordination level matching models still perform poorly. Rank fusion, on the other hand, is an unsupervised method to combine multiple rankings into a single ranking. For example, you might have one query with many systems, and you want to combine those rankings from many systems into a single ranking. Rank fusion has been shown in the past to significantly outperform existing baselines by combining already existing ranking methods. Our contribution in this presentation is coordination level fusion. We present the intuition for coordination level fusion with two observations. Observation 1 is that coordination level matching ranks documents using the intuition that a document retrieved by many clauses should be considered more likely to be relevant. Observation 2 is the chorus effect of rank fusion, which suggests that the more ranked lists a document appears in, the more likely the document is relevant to a query. Coordination level fusion leverages these observations to further boost relevant documents higher in the ranking using the agreement from multiple ranking functions and the agreement afforded by the structure of the Boolean query. We perform rank fusion on several lists obtained at the lowest level of a Boolean query, a single keyword in a query. There is no structure here, so any contemporary ranking function may be used. We then apply rank fusion at each Boolean clause in the query to obtain a single ranked list for the entire query. I will now give a visual description of the coordination level fusion process. First, several rankers are fused to produce rankings for each keyword in the query. This is performed for all keywords in the query. Next, the fused rankings are fused again at the clause level. We use a different rank fusion method depending on the Boolean clause. The clause fusion is performed again for each clause in the query. The fused rankings for subclauses are then fused iteratively until the top-level clause in the Boolean query fuses its subclauses. What results is a final ranked list of documents for a Boolean query. We also explore a gain cutoff using the final ranked list produced by coordination level fusion for the systematic review task of stopping prediction. Recall that the aim of this task is that given a ranking of the set of studies retrieved by the Boolean query, at what position should we stop screening? We model this task with an equivalent question. Given a set of studies retrieved by a Boolean query, what is the subset of studies which does not need to be screened? We model this using the intuition that researchers screening studies accumulate gain from observing a study. We approximate this gain as the score assigned to each study after ranking with coordination level fusion. And we tune a parameter to estimate the total amount of gain to reasonably stop screening. Now, with the knowledge of how coordination level fusion works and the tasks that we're trying to address, I'll now first present the results of our screening prioritization experiments. We perform these experiments on the Clay TAR 17 and 18 tracks. We use a total of 9 ranking functions at the keyword level, as well as query expansion. There's not enough time to divulge into all of the detail here, but I implore you to go and see the paper for full details. We evaluate our experiments by comparing our coordination level fusion approach to the best 2 runs of participants of the Clay TAR 17 and 18 tasks. The 2 tables on the right-hand side illustrate these results. Our baseline is the ranking that PubMed, one of the most prominent literature databases, produces for queries. We find that overall, coordination level fusion is significantly better than the baseline PubMed ranker, and also outperforms all of the participants in many of the evaluation measures that we tested. And here are our results for the stopping prediction task. These experiments were performed in the same dataset, and we also compare the runs from participants to the Clay tasks. The baseline in these experiments is the retrieval of studies without using any cutoff. Note that in this evaluation, we're more concerned with the set of studies retrieved and less concerned about how well ranked they are. In the Clay TAR 17 dataset, coordination level fusion outperforms all of the participants in many of the evaluation measures tested. We also include the results of the Clay TAR 18 data. However, no participants submitted runs for the stopping prediction task for this year. We find that using our stopping prediction with coordination level matching significantly improves precision, with the trade-off in a reduction in recall. However, we found that this reduction in recall is within a tolerable amount. The main contribution of this talk is coordination level fusion. We found that it outperforms the state-of-the-art for 2 different tasks. We also found that our method significantly outperforms PubMed's own ranker and participants to the Clay TAR tasks. We also performed a cost-based analysis which found that using coordination level fusion can significantly reduce the cost associated with producing a systematic review with tolerable losses in recall. and there is a high applicability for this method to be used in the construction of rapid reviews. These are a form of systematic review that are performed quickly and less systematically. For future research, we plan to embed coordination level fusion into an active learning setting, to use coordination level fusion as a query performance predictor, to extend coordination level fusion by learning weights for different rankers, and to investigate different rank fusion methods to further improve the effectiveness of coordination level fusion. Thank you for your time and attention.